Okay, in this video we are going to look at how to solve a trig equation graphically. So we are going to use our calculator for these types of questions. So if the question says to solve and it doesn't say we need exact answers, if it doesn't say it has to be done algebraically, then you want to take full advantage of your calculator and solve this graphically. So I want you to refer back to question number 8 from the trig equations packet that we just finished working in. So from that, here is the equation that I have in here in red. We are looking to solve from 0 to 2 pi, and off to the side here I wrote down what the solutions were. Now these were exact solutions. There was no rounding here. These were exact values. They are in terms of pi. There was no 3 sig fig rounding. Okay? If we are solving a trig equation using our calculator, if we're doing it graphically, then what's going to end up happening is we're going to have non-exact values that we're going to end up having to round. Okay? So suppose we wish to solve this equation. So the first thing to be aware of is what mode your calculator is in. So I need you to make sure you have a calculator out in front of you. Okay? You're going to go through this process with me. I know I do not have a calculator on this screen, but I'll do my best to explain what you need to be doing. So first off, make sure your mode is set to radians. Because we see 2 pi, it tells us we're in radians. Next, if we're looking to solve this graphically, a lot of times it makes sense to just get this equal to 0, bring everything over to one side, so you just have one equation to enter. Another option is you could enter the left-hand side into y1 and the right-hand side of our equation into y2 and find the intersection point. But I'm going to encourage you, at least in this video, I'm going to have you bring everything over to one side. Okay, so we have 4 cosine squared of x and then minus 3 equals 0. So on our calculator, after we enter this into y equals, we're going to use the 0 button, which is found under second trace. We've used this before. Now, one of the most challenging parts about this problem is knowing how to actually enter it. The cosine squared piece can be a little bit tricky. So we need to enter 4 and then a parenthesis. Alright, this is all in y equals. So 4, and then a parenthesis, we have the quantity cosine of x. Now, it will start a parenthesis there for you, close it around the x, and then close it one more time, and then we're going to square it. It's really important that you remember that second parenthesis, because if you don't, then you end up squaring only x, and we want to square the entire quantity. Okay, so we have 4 times the quantity cosine of x squared. So look at what I have here. All right, you should have a total of 2 open parentheses and then 2 closed parentheses as you enter this. Okay, and then you have your minus 3. Okay, now don't be quick to hit graph. Go to your window. All right, now in your window for your x min and your x max and your x scale, well, this is simply going to be what they tell us in the problem, 0 to 2 pi. All right, now 2 pi is about 6.18, so we can keep it at 1. All right, we can go by ones. All right, and then for the y values, usually it's going to be within 1 and negative 1. However, we are squaring things, so why don't we go a little bit beyond that? So let's set our y min to be negative 3. And sometimes you just have to do some experimenting, all right, to make sure that it's going to give us a full view of our function. Okay, a negative 3 to 3 with a y scale of 1 will be sufficient to see this function. Okay, so we're in radian mode. We've entered our function using parentheses. All right, we've set our scale, and now we're going to hit graph. Okay. So if you entered it correctly and you graph it, this is what you should see, all right, on your screen. So we need to sketch that onto our paper. It doesn't have to be perfect, okay? But this is our function. We're going to label this. This is y equals 4 cosine squared of x minus 3. So we are interested in where we have zeros. Well, the zeros occur right there. Okay, so that's where the function is equal to 0. So you need to circle them, and now we need to use the calculator to find the zeros. Now we've done this before, okay, but a quick review if you forgot. Second trace, you're going down to number 2 where it says 0. You're going to hit enter. Now it's asking for the left bound. So let's suppose we want to find the smallest value first. So you're going to arrow all the way over to the left so that your cursor is slightly to the left of it. Okay, it looks like it's above the curve, all right, but it's also to the left. All right, hit enter. Then it says right bound. Arrow over to the right, hit enter. Then it says guess. Just hit enter one more time. All right, and then near this, you need to write down that this is x equals 0.52. Now, if we go to 3 sig figs, it would become a 4. Okay? Well, if we were to repeat this process, okay, we would have the other 3 answers. Now, you can see there's 4 total. Just like before, we got 4 exact solutions. Okay? And we know we're correct because if you were to take our first answer up here of pi over 6, all right, and punch that into your calculator, you would see that it's approximately equal to the value we just got. Okay, so if we were to express all of our answers to 3 sig figs, it would look like this. So again, we get those solutions by repeating that step of finding the 0 in our calculator, and we know we're correct if we were to compare it to our other ones. If we were to take these exact solutions up above and throw these into the calculator on a blank screen to see the size of those numbers, you would get these 4 values down here. Okay, again, the difference is exact solutions versus down here solutions to 3 sig figs. Okay, now if this were in degrees, we would go through the same process, except this time we would have to make sure that our calculator is in degree mode, and whatever you have for your interval given, maybe it's 0 to 360 or negative 360 to positive 360, you would want to enter that. For your x scale, usually you go by 90s if you are in degrees. Okay. One more thing, we want to make sure that you guys know that you absolutely have to have this graph on your paper, and you need to make sure you're labeling all of these solutions. All right, so where we circled these zeros, we need to make sure you write nearby what the actual x value is. All right, that's how you show your work. All right, yes, the work is done in the calculator, but on your paper, you need to actually provide a sketch and mark it up like I showed here. You don't have to have the window marked or written down on your paper. That's not necessary. But certainly you should label your equation, mark your roots, circle them, and you're good to go.